From Tycoon News Studios in Delray Beach, Florida, this is Options GPS with Chris Rowe and Ron Ianieri.
Hey, welcome back to Options GPS. I'm Chris Rowe.
And I'm Ron Ianieri.
And the next thing that we're going to talk about are the Greeks. Now, when it comes to the Greeks, once you understand what the Greeks are, basically turns the lights on in the room. It's really the tool that you need to understand risk management in options.
People talk so much about risk management anymore. It's so important. Oh, that, risk management this and risk management that. The beauty about the options market is there's a set of statistical references spit out by the option pricing model that tell you an option's sensitivity before you jump in. What's my option going to do if volatility changes? What's my option going to do as time passes, as the stock moves? And the beauty about the Greeks and why they're such an incredible risk management tool is that the Greeks not only identify what your risks are, they quantify them for you. And that's why they're so important.
Well, you talk a lot about risk here, and I think it was Warren Buffett who said risk is not knowing what you're doing. And that's what it comes down to when it comes to learning about the Greeks. Once you understand the Greeks, you see these options as something completely different, a different vehicle, and you find ways to take advantage of them.
No doubt about it. And I know one of your favorite Greeks is Delta, because Delta talks about directional movement and how the stock and the option move in tandem in a percentage way. And why don't you tell us why you like Delta so much?
Well, people love learning about Delta, and it's pretty easy to teach. That's one of the reasons why I like it so much. It gives me an advantage, and it makes me sound really smart, especially when I say the word Delta. No, but back to reality. The fact is that Delta, once you learn about it, most people are comfortable when they start trading options with stock replacement. So instead of taking a long position in stock, they'll just take a position in a high Delta option. And you're going to learn what that means soon. But basically, the best part about this is that when you do stock replacement and you understand Delta, you start to understand that when you're right, you make a lot more money than you would lose if you were wrong. So if stock trades up 10 points, maybe you'll make 8 or 9. Stock trades down 10 points, maybe you lose 6.
Well, the thing I think is crazy is that I don't know any other investment in the world that people actually put money on without knowing the risks beforehand. Yet so many other option instructors save the Greeks for last. It's considered an advanced topic. You got to know these things first. You don't buy your car insurance after your son comes home and says, Dad, I put the car into a tree last night.
Yeah.
You've got to have that beforehand. And the reason why we're going to teach the Greeks first instead of last is because we believe you should know the risks of your potential investments before you make them and not after it, because afterward, it's too late.
Yeah, knowing the risk before they put real money in it, it's probably the best idea.
And the beauty of it is, like I said, the Greeks tell you all about every possible risk you can have, and down to the penny of what that risk is going to be ahead of time. So why don't I go over and show you, and we'll start with Delta.
Let's do it.
All right. One of the interesting topics in option theory is called the Greeks, and the Greeks are obviously very important. A lot of instructors hold off the Greeks until the end, figuring that it's more of an advanced class. But the problem is that without knowing your Greeks, you don't know your risks. And who should make any investment without knowing the risks first? So if we want to know about risk and we want to be able to manage risk, we have to know the Greeks. So what are the Greeks? Well, first off, we need to know where the Greeks come from. The Greeks are part of the option pricing model. Now, many of you think that, hey, the option pricing model, that's the model that throws out the theoretical value of an option. You're right. However, you've got to realize that the option pricing model is more than that. The option pricing model not only throws out theoretical value, but it also throws out these Greek sensitivities. So what the Greeks are is a family of statistical values calculated and given to us by the option pricing model. They are basically the risks of our position, but told to us before we enter the position, which of course is good because we don't want to find out about something after it happens. So what the Greeks actually do is they actually measure an option, individual option, or an entire position's sensitivity to changes in different variables. Those variables being move in stock price, movement in volatility, and the passage of time. Now, all you have to do when you think about the Greeks is think about risk management. And we know today risk management is a very, very important part of trading. Everybody's talking about risk management. Well, the Greeks is your risk management. That is risk management. It weighs and views every single potential risk that options can have. And it not only tells you what those risks are, but it actually quantifies it for you. There's a big difference between knowing that I'm in danger and knowing exactly how much danger I'm in, where that danger is, and of course, how I can avoid that danger. So let's meet the Greeks. What are the Greeks? First, we have delta, known as the first derivative. The second Greek we're going to talk about is gamma, which is the delta of the delta. The third Greek is time decay. And finally, our fourth Greek, volatility sensitivity, is vega. Our first Greek that we're going to talk about, and the one that you're probably going to be a little familiar with, or at least have heard of before, is delta. Delta is known as the first derivative because it's the first step from the actual underlying. Delta has several definitions. These definitions are functioning all at one single time. The first definition is percent change. How much is my option going to change in price with a $1 movement of the stock? We have to know that when we say percent, delta is given as a percentage number. When you see a delta number of 70, it means 70%. If you see a delta number that says 0.70, that is also 70%. So depending on your brokerage firm, you might see delta given as either a whole number or a decimal. If you see it as a whole number, it means that number percent. If you see it as a decimal, of course, we're talking hundreds. It's obviously a percent. But we need to know that when we see our stock move, we need to know what our option is going to do. And that's what delta as percent change tells us. So say, for instance, we have a stock that's $100 and it goes from 100 to 101. We've got a $1 movement. The delta of our option is going to tell us how much our option's price will change with that $1 movement in the underlying. So a 70 delta option, 70%, will see a movement of 70% of the stock movement. If the stock moves $1, then my 70 delta option will move 70% of that dollar, or 70 cents. If I had a 30 delta option and the stock moved $1, then my option price will change 30 cents, 30% of the $1 movement of the underlying. Real quick, if you had a 50 delta option and the stock moved 50 cents, what will be the change in your option price? 50% delta, 50% of 50 cents, or 25 cents. Very simple math here. It's nothing really complicated. But this allows you to know ahead of time, before the stock moves, what's going to happen to your option if the stock goes up 50 cents, $1, $5, $10. Also, it tells you what's going to happen in the other direction. What happens to my option if the stock goes down $1, $5, $10? So that's delta as percent change. Now, occurring at the same time, but just as equally as important, is delta as percent chance. What is the percentage chance of my option finishing in the money by expiration? So while percent change is looking at delta saying 50 delta means 50% of the stock movement, percent chance is saying 50 delta means a 50% chance that this option will be in the money by expiration. So when we're looking at delta, we've got these two definitions. Both are valid at all times, both happening at the same time, just two different ways of determining the risk of our position. Percent change, what is our price risk to dollar movement in the stock? Percent chance, what's the chance of our option finishing in the money with value at expiration. Finally, we have to look at delta as a hedge ratio. Remember, we've got three definitions here. Delta is like a three-headed monster. Every one of these definitions is valid at all times. They're all functioning at the same time, just different ways of looking at everything. Hedge ratio allows us to hedge our position. Have you ever heard of hedging your position? Fund managers quite often don't do that, and I'm sure many of you have witnessed that in the past. But the fact of the matter is that if you know the hedge ratio or the delta, you would be able to hedge any single individual position and any entire portfolio that you might have for whatever reason you want to hedge it. Now, when we talk about hedge ratio, we have to consider delta and its definition of equivalent share position. What do I mean by equivalent share position? Well, if I have a 50 delta option, a 50 delta option acts as if it's half of a full contract. Now, we know that an option contract represents what? 100 shares of stock. If I have an equivalent share position, meaning that my delta, my percentage, is going to act a percentage of an entire contract, then I have a general idea of how many shares my position is going to act like. We know that one contract is 100 shares. If I have a 50 delta option, it means that my option will act from a P&L standpoint the same way as if I had 50 shares. If I had a 70 delta option, then I know that my position will act the same way as 70% of a contract, which would be 100 shares. 70% of 100 shares is 70 shares. That's what they mean by equivalent share position, or some people say equivalent stock position. So when we're looking at that, once I know exactly how my position is going to act and how many shares my position is equivalent to, I can now go into the underlying market or another option and hedge my position to eliminate any type of potential adverse movement. Now, depending on whether you're short in your position or long in your position, adverse would have a different definition. However, if I know how many shares my position is equivalent to, I can always hedge it for whatever type of adverse movement I'm expecting. So hedge ratio comes into how many options or shares of stock it will take to hedge the position delta neutral. What do we mean by delta neutral? It means, remember, delta is what? Representative of my stocks, my options reaction to the stock movement. So if I'm looking at my options reaction to the stock movement, and I know that my option is worth an equivalent amount of shares, say 50, I know how to then hedge my position to eliminate my risk of stock movement. Now, some people, especially you stock traders out there, might be saying, Ron, why would I want to eliminate my ability to trade direction? Well, sometimes you have a position where you don't want to have the risk of direction. Many of the premium collection strategies that we're going to be talking about in the future are delta neutral strategies. They're simply there to take advantage of premium collection and eliminate the potential risk of us losing money in that position because of a stock movement we weren't anticipating, or even more, didn't want. Now, let me show you a little how delta works. Remember this whole big, pretty bell curve we had here? We said that when we have this bell curve, we're talking about the probability of outcomes of the stock price. When we said that whenever we buy a stock, no matter what price we buy it at, the bell curve is drawn directly over that price. And right now, let's just say that we bought the stock at 50, and we're talking about the 50 strike. Well, if we purchase the stock at 50, right here, and we're talking about the 50 strike, we know that if the stock moves up, that 50 strike would be in the money and would expire with value. That's what that red area is. However, if the stock went down from 50, the 50 strike would lose value, wouldn't it? and this is obviously for calls, it would lose value. It would expire worthless. So we know that when the stock price is directly at the strike price, we're talking about a 50 delta option. Why? Think of delta's definition as percent chance. There's a 50-50 chance that the stock will either go up or down from here. It has an equal chance of moving in either direction. What was that again? Random walk. Here's where random walk's coming in. The stock has a 50-50 chance of going in either direction. If we are dead center of our bell curve with a 50-50 chance in either direction, what do we have? We have half of our area colored in. Up means we make money and there's value. We might not necessarily make money. We might have spent too much for the option, but we'll get into that later. But up means that the option will expire with value. Down means the option will not expire with value. Now, let's change our strike. We're still talking about the stock at $50. How do I know we're talking about the stock at $50? Because current price of the stock, $50, right down the center. When we're talking about the current stock price, that's the center of the bell curve. Now we're going to look at an in-the-money call, the 45 strike. And as you can see, with the stock at 50, the 45 strike has a lot more than a 50-50 chance of expiring in the money. When we look at that strike, we can see that we've got a very large percentage chance of expiring in the money. Why? Because now, if the stock goes up from 50, we expire with value in the money. But when the stock goes down from 50, say down to 48, we now are still in the money, aren't we? Because we own the 45 strike. At this point in time, the difference between this graph and our last one is that even if the stock goes down, we can still wind up in the money. Percentage chance. Higher percentage chance now because we still have the ability to expire with value if the stock goes up, but now we even have some ability to expire in the money if the stock even goes down a little. It can actually go down and still expire in the money. Percent chance. There's now a greater percent chance that the stock will finish at a point where our 45 strike will remain in the money, even if it works against us. That's why in-the-money calls have a higher delta, a higher percentage chance of finishing in the money. Now, going the other way, let's take a look at a strike that would be considered out of the money, the 65 strike. Again, we're still looking at the stock at 50. We're straight down the center of our bell curve. But now look at the difference. The percentage chance of this strike becoming in the money is much less. Why? Because now the stock not only has to move a little bit to the right or to the right at all, now it's got to move a lot to the right before the 65 strike has a chance of seeing some value at expiration. So the percentage chance of the 65 strike becoming in the money is very, very limited. That's why out-of-the-money calls have a lower delta. The in-the-money calls like that 45 strike we were looking at has a high delta. It's going to mimic the stock very closely. This here, the 65 strike, this out-of-the-money call, has a very low delta. It's not going to mimic the stock all that much. And the stock really has to move a lot before we start seeing any type of profitability. This is why you're going to learn when we talk about stock replacement, this is not the option to buy for stock replacement. I'll give you a guess as to which one is. Now, let's get back to our bell curve, stock at 50. Let's talk about the 50 strike, but let's look at the puts this time. Let's look in the other direction. One of the things that you're going to have to realize is although it sounds like they're opposites, because a call gives you the right to buy, a put gives you the right to sell, a put and a call are actually very similar because their mechanism, the mechanics of how they work, is identical. And it always made me wonder why people have no problem trading calls, but they have trouble trading puts. The fact of the matter is, from a mechanism standpoint, they're identical. So let's look at how identical they are. Here we have a stock, 50. We've got our bell curve right down the center. It's actually a very nice drawing, very accurate. I didn't do it. Now we have the 65 strike. But look, this time it's a 65 put. Suddenly, with us playing downside, this 65 put, which would be considered an in-the-money put, it was out of the money as a call, but it's an in-the-money put. Look at all the potential chance of that option expiring with value. Remember, the stock is currently at 50 right now. Even if the stock moved up against us, the 65 strike would still be in the money come expiration. That's why it has such a higher chance of being in the money at expiration, because the stock not only can go down, but it can also go up against this, and the 65 strike still remains in the money. High percentage chance means what? High delta. High delta, in the money put. Let's take a look at the other way. Now suddenly, we're looking at the 35 strike, which was an in the money call. It's now an out of the money put. Stock is at 50. Now, even if the stock goes down, it's got to go down a ways before the 35 strike becomes valuable at expiration. If the stock goes against this, we already know that we are not going to see value at expiration. But with the stock having a 50-50 ability to go in either direction, we suddenly see the chance of the 35 strike being in the money at expiration very remote. It's already out of the money. It's probably going to stay out of the money. Look at the percentage chance. Percentage chance of being in the money in red is overwhelmed by the percentage chance in white of it not being in the money at expiration, not expiring with value. So when we're looking at this right here, it's giving us a good idea of delta as percent chance. Out of the money put, small percentage chance of finishing in the money by expiration. What does that mean? It means it's got a small delta. Now let's just review our delta of calls, because now that we know what delta is, we need to really look at delta and say, hey, how do I apply this to the options? Well, the delta of calls, first thing we have to know is that the call delta is positive or long. When I buy a call, I become long delta. Now, we have three types of calls, three different types: in the money, at the money, and out of the money. Each one of these different calls is going to have a different delta, different characteristics, different ways of mimicking or not mimicking so much the stock. Let's talk about the delta of puts. Delta of puts are the opposite. Instead of positive and long, put deltas are negative or short. When you buy a put, you actually become short in your position. Now, this is an old joke, not really a joke, because I've had a lot of people come up to me and not understand that when they buy a put, they become short. And they say, Ron, I don't understand it. I bought it. And I say, yes, but now you're short. But I bought it. I didn't sell it. It's like almost like a Laurel and Hardy episode or Abbott and Costello going back and forth about long and short. The fact of the matter is you are long the put because you own it. But the ownership of the put gives you the right to become short. If you exercise that right, you are going to become short the underlying. So that's why the deltas of puts are negative. You own the put, you're long the put, but you become short delta in your position. We also have the difference between in the money, at the money, and out of the money puts. Now, there's a little thing you need to know here. It's very important for the future, but you might not understand it now. I'm going to give it to you now. Write it down and remember it, because we're going to use it a lot going forward. And that is the delta connection between corresponding puts and calls. Now, what do I mean by corresponding? Corresponding is a put and a call of the same month and same strike. June 40 call, June 40 put. April 90 put, April 90 call. Those are corresponding options. Any call and put with the same month and strike. Now, if I take those two options and I take their deltas and I take the absolute value of the delta of the call and the absolute value of the delta of the corresponding put and add them together, it's going to equal 100. And you might say, well, I don't know why that's possible. Well, remember, there's only a 100% chance of anything happening. And if that's true, then we either have a put that's in the money or a call that's in the money. No matter where the stock finishes, if we look at a single strike, month and strike, either its call or its put has to be in the money. So if we have a stock that's trading at 100, if the stock closes at 90, the 100 put is going to be in the money. If the stock closes at 110, the 100 call will be in the money. One of them has to be in the money. The other has to be out of the money. Because together, they add up to a 100% chance of outcome. Think about your bell curve. Now, why is that important? How does this work? I mean, where's the concept? Well, think about it. If I have a call that has a 70 delta, and remember, 70%, 70 delta, that 70 delta has a 70% chance of finishing in the money. So if the call has a 70% chance of finishing in the money, then it has a 30% chance of not finishing in the money. And if it doesn't finish in the money, then its corresponding put had to have finished in the money. So if you think about it, all the delta of the put is the inverse of the delta of the call. If I know that my call is a 70 delta and has a 30% chance of not finishing in the money, then the put must have a 30% chance of finishing in the money. It has to, because on that 30% chance that my call falls out of the money, the put now becomes in the money. Why? Because one of the two has to be in the money at all times. The other is out of the money. What we have here is a delta chart, and the reason that I have this up is I want to show you what delta looks like over the different strikes. Now, you might wonder where I got these numbers. You know where I got these numbers. I got these numbers directly off the trading sheets that you're using. Sheet number 1, these are the deltas of Qualcomm at a 30 volatility with a stock price of $65.50. And we're looking at the calls right here. And what I wanted to show you was just how delta moves and looks both vertically and horizontally across all the different strikes in the different months. Let's first take a look at June. We know that the 65 strike is the at-the-money strike, okay? Obviously, because the stock's trading at $65.50. Remember, the strike that's closest to the stock price. And when we take a look at that option, we see it's got a delta right around 50, as it should. But let's start taking a look at what happens in either direction vertically. The first thing we want to observe is the range. As you see, we've got a 50 strike, which would be an in-the-money option, in-the-money call, and the 80 strike, an out-of-the-money call. And look at the range of deltas in June. We go from a high of 100 down to 0. What do we see here? We see that we've got the June 50s and June 55s, both 100 delta. What does that mean? It means that they will mimic the stock movement to 100%. If the stock goes up $1, these options will go up $1. If the stock goes down 30 cents, these two options will go down 30 cents. Percent change. We also know that we've got what? Percent chance. 100% chance that this option will finish in the money. 100% chance that this option will finish in the money. Now, what you need to know about that, because when you anytime you see something that's a 100% in the market, you know to be wary. The reason these are 100% is because under this volatility, with this stock price and all the different other variables kept together, kept alike, not moving. These two options have a 100% mathematical chance of remaining in the money. That's what we have to realize. Do understand, some type of catastrophic event in the market, some geopolitical event, could then change things because it's going to move the stock dramatically. Keep in mind that these are with all other things being equal. With all other things being equal, with the stock at this price, with 18 days left till expiration in June at a 30 vol, mathematically, the stock cannot get below 55. That is what that is saying. Now, we also have another option, the 60 strike, which is a very deep in the money option. It's got 91 deltas. That means it's going to mimic the stock to 91%. It's going to change price 91 cents on the dollar to the movement of the stock. We have our at the money option, and then we've got some out of the money options. The 70, the 75, and the 80 strike are all out of the money. You might say, hey, wait a second. How can the 80 strike have zero chance of being in the money? There's still time left, and I agree with you. It shouldn't really be zero. But the fact of the matter is the reason you're seeing zero is because with the stock at 65, with 18 days left till expiration, at a 30 volatility, with all other things being equal, there's no way that the stock can get to 80. That is what that's saying. Now, when we look at the 70, 75, and 80 strike, we see very low deltas. That means these options are not going to mimic the stock too closely. The 75 is only going to mimic the stock 18%. The 70, 18%. The 75, only 3%. And the 80, 0. So when we see the 75 strike and we see this 3 deltas, that means for every dollar movement in the stock, this option is only going to change 3 cents. That's it. So when we're looking at these out of the money options, we've got to be saying to ourselves, if we're trying to trade stock direction, we're not going to have the mimicking power we really want in these types of options. Their percent change is not going to be what we're looking for to use for stock direction. Now, let's talk real quick about equivalent share position. Remember that one? Equivalent share position. This option here, the June 50s, 100 delta. Equivalent share position, 100 shares. That makes sense because if this contract is going to act 100% of a real contract, 100 shares, then it's going to act like 100 shares. Simple as that. We know the contract is equivalent to 100 shares. This option is going to act 100% of a contract. It's going to act just like 100 shares. However, the 70 strike down here, 18 deltas. Its equivalent share position is 18. Your single contract is going to act like 18 shares. We know that a contract has 100 shares. This contract is going to act like it's only 18 shares. That's where the equivalent share position comes in. Now, as I said, we have a range of 0 to 100. But when we move out to July, look what happens. Our range starts to decrease. We now only have a high of 99 deltas and a low of 4 deltas. Our range has tightened up. And if you can see as we go out, month after month, our range continues to tighten. Why? Because as we go out in time, these options here, with the extended time, have now more chance of finishing out of the money, which means they have less of a chance of finishing in the money. So if this option here has less chance of finishing in the money than this option here, its delta has to be lower. This in the money call has only a 90% chance of finishing in the money. Why is that different from this in the money call? They're the same strike. The difference is that this expiry month, June, only has 18 days until expiration. The model is saying that this stock, priced at $65.50 with a 30 volatility, 18 days is not enough to move this stock down below $50. However, if we go out to January, take a look on your sheets and look at how many days to expiration January is. It's a hell of a lot more than 18. There's a heck of a lot more time for this option to fall out of the money. Now suddenly, this $65 stock, even at a 30 volatility, has an actual chance of trading down and below 50 by January. That's why this option here, the January 50s, has a lower delta than the June 50s. So that you know, at any given strike, as you go out over time, you're going to find that the delta of the in-the-money calls decreases. Why? Because now there's more chance or likelihood that the option won't finish in the money, thus taking away from the delta. Why? Delta is percent chance of finishing in the money. If there's more chance of me now finishing out of the money, there's less chance of me finishing in the money. Thus, a lower delta. And you can see that through the 55 strike and the 60 strike. The delta continues to go lower. However, take a look at the 65 strike, or at the money strike. If you notice, its delta stays relatively constant all the way throughout. Why? Because if it's 50-50 now, it's going to be 50-50 next week. Remember, this stock price is kind of a line in the fence. It's like it's a fence, and you're walking the fence. Fall to the right, you're in the money. Fall to the left, you're out of the money. Well, I could fall to the left or right as soon as I hop on the fence. But if I'm a good balancer, I could walk the fence for a while before I fall off left or right. The amount of time doesn't matter because the stock price movement is 50-50 to either side. Remember random walk. So thus, anything that's directly at the money now that has a 50-50 chance today is going to have a 50-50 chance no matter how much time there is. Now we got to look at the out of the money options. They look a little different when we go out over time than the in-the-money options, don't they? The in-the-money options delta decreased. Is that happening here in the out-of-the-money options? No. In the out-of-the-money options, what we're seeing is an increase in delta. Why? Think of percent chance again. With 18 days, this June 70 strike only has a 3% chance of finishing in the money. Why? Because at this stock price, with this volatility, all things being equal, there's only a 3% chance that the stock will trade and finish at expiration above 75. However, if I add more days to the equation, if I go out to July, where I have more days to expiration, with more days to expiration, it means there's more time. With more time, there's more chance of this option finishing in the money. Now it's a 13% chance. Why? Because we've got more time. Remember, we said time walks hand in hand with volatility. Time gives more room for volatility to move. So when we're looking at this, suddenly, as we add more time to the equation, the option has more chance of becoming in the money. Because with more time, there's more likelihood of enough movement to get that strike into the money by expiration. So what we see here is an effect in the money options of a decrease in delta over time when we're looking out into time, but an increase in the deltas as we look in the out of the money options. They increase over time. Look at the ranges. Look how the range is 0 to 100 here, but 26 to 90 out in January. That crunch is being caused by additional time. More time for the in-the-money options to fall out of the money. More time for the out-of-the-money options to get into the money. And that's why we're seeing these numbers increase, pushing toward that middle ground. These numbers decreasing, pushing toward that middle ground. Now we have the puts. Our X in the money calls are now going to be out of the money puts. And our X out of the money calls are going to be in the money puts. If we take a look real quick and maybe take a couple examples of that relationship between corresponding options, what do we see? Take the absolute value of, somebody throw me one. Which one? October? October what? 60s? Let's look. October 60s. The delta of the call is 72. The delta of the put is minus 28. Absolute value of the call, 72. Absolute value of the put, 28. Remember, absolute value means take away that minus sign. What's 72 and 28? Get out your calculator. Yep, carry the 1, bring it over. 100. One more, and just in case you don't believe me, now remember, you have these sheets at home. You should go through a bunch of these. You don't have to spend a weekend doing it. Spend 20 minutes, do 10 of them, and make sure that you see it every time. You will find some occurrences of them adding up to 101. Rounding error. Remember, the model's not perfect. I might be, but the model isn't. Now, take a look at, here we go, July 70s. Now let's go in the money. Let's go July, hey, what the heck? July 55s. 95 delta on the call, 5 delta on the put. One more? One more. June 70s, 18 deltas on the calls, 82 on the puts. My goodness, what a trick. It works every time. And it does work every time. And why? Because of the concept. One of these two has to be in the money. There's only a 100% chance of anything happening. It's either going to be in the money or it's going to be out of the money. If one's in, the other's out. So they have to have a percentage chance combined that equals 100. Because come expiration, one of them has to be in the money, the other has to be out of the money. Simple. Now, take a look at put deltas here, and let's look at them vertically. Obviously, we're looking at out of the money puts being in the money calls. We're looking at in the money puts being the same strike as your out of the money calls. Let's see what this says. We see a delta here of a minus 44 for our June 65s. This is the at the money strike. Now do understand, the at the money strike can be slightly in the money or it can be slightly out of the money. In this case, with the stock at 65.50, our at the money calls were actually 50 cents in the money. Our at the money puts are actually 50 cents out of the money. That's why you have the call being a bit of a higher delta than the put. Now, what does this mean? This means that by June expiration, the 18th, 18 days away, on your sheets, check it. It says expiration, days, 18. With 18 days to expiration, what are we going to see? There's a 44% chance that this June 65 put will finish in the money. Percent chance. What about percent change? This put is going to change 44 cents per every dollar of stock movement. What about equivalent share position? This put is going to act like 44 negative shares, 44 short shares of stock. Take a look at this one, the June 70s. Now we're moving in the money. The June 70s are in minus 82 deltas. Remember, owning a put gives me the right to become short. That's why these deltas are negative deltas. I have a June 70 put here, 82 deltas, negative 82 deltas. It means that its price will change 82% of the stock movement, 82 cents on the dollar. It also means that this June 70 put has an 82% chance of finishing in the money. Give me one other thing it means. This option will act like 82 short shares compared to a full contract. Remember, equivalent share position? If we take a look at the range here, we see the range mimics the range of the call deltas from the other side, just flipped over. We've got what? a delta here of minus 100, it means that this June 80 call has a 100% chance of finishing in the money. Excuse me, this June 80 put has a 100% chance of finishing in the money. How is it possible that anything has a 100% chance in the market? It doesn't. What it's saying is that this June 80 put, that 100% chance is based on a stock price of $65.50, a 30 volatility with 18 days left. Mathematically, this June 80 put has to finish in the money. The stock cannot move enough under this volatility assumption in 18 days, all things being equal. This stock can't move enough to make this June 80 put fall out of the money. It means that the stock can't go from 65.50 up to above 80 in the allotted time. It's a mathematical situation. Do understand. Can things change? Sure. Major news announcement, either in the stock or the market in general, geopolitical crisis. There's a million things that can happen. But when we're looking at these, we've got to remember these are mathematical statistics that are based upon these certain inputs with everything else screened out. Now, let's take a look at what happens when we move out to July. Look at the range here, 0 to 100. Suddenly the range tightens, 98 to 1. We move to October, it tightens more, 84 to 6. Tightens more as we move to January, 76 to 10. The same effect of time on the call deltas is affecting the put deltas. These out-of-the-money options that have no chance of finishing in the money in 18 days, the 50 strike and the 55 strike, suddenly have a little bit of chance of finishing in the money when we add another month to the equation. Add even more time, their percentage chance of finishing in the money increases. Add even more and it increases more. What you have to remember here, what's going on here, is that although these strikes here in June with 18 days can't finish in the money, more time added gives more chance for these options to finish in the money because volatility is a product of time. The more time under this volatility, the more chance for a bigger swing in the stock, giving these out-of-the-money puts more chance of becoming in the money as they have more time and as the stock swings more under volatility. What happens when we go to the at-the-monies? Look at that. The at-the-monies stay pretty much the same all the way through. Something that's 50-50 today is going to be 50-50 tomorrow. What about the in-the-monies? We see the same effect with the in-the-money puts as we see with the in-the-money calls. As we go out over time, these deltas decrease. Remember, the out-of-the-money deltas, out-of-the-money puts were increasing. So were the out-of-money calls. Here, the in-the-money puts, like the in-the-money calls, are decreasing deltas over time. Why? Because the more time there is, the more time for something to happen in the stock. The more time, volatility will move the stock more. Remember, volatility is a product of time. The more time, the more range volatility adds. So when we're looking at these, we see that as time increases, there is less chance of these options staying in the money because there's more time, giving more chance for the options to fall out of the money as the stock moves more. Think about range when you're thinking about this. Think about range. When I look at a 30 volatility, I know that for the year, the stock will have a range of 30% up and 30% down. For 1 month, though, it's only going to have 1/12 of that potential movement. That's why these options here don't have a chance of A, these in the money, these out of the money options getting in the money, and these in the money options falling out of the money. Because the range for 1 month of the stock is lesser. However, as we go out further, remember, 30 is an annualized number. Volatility is an annualized number. As we add more time to it, the range of the stock grows, because where we were 1/12 of 30% of 65, we're now 2/12 or 1/6 of 30% of 65. The range of the stock during these time periods is growing. The more range that the stock has, the more likelihood of the out-of-the-money options becoming in the money, and the less likelihood of the in-the-money options staying in the money, thus a lower delta. Let's talk about position delta, and let's talk about delta neutral. An individual option has its own delta, but combinations of options can have a delta that is a summation of all the individuals under a single stock. Later, you're going to find out that it's also true for an entire portfolio. A delta, one single delta, is equivalent to one single share of stock. So if we would decide to take our option positions and have a bunch of long deltas and have a bunch of positions that are short deltas, combine the longs and shorts, if they come up to zero, if they cancel each other out and come up to zero, we are delta neutral. Now, I know for you stock traders, it's hard to think of a position where you have no stock position but make money. Here in the options market, it's different. Remember, in the stock market, one way of making money, you got to be in the right direction. You've got to buy a stock and have it go up, or you got to short a stock and have it go down. That's it. The only factor is going to be the movement of the stock in terms of your P&L. However, in the options market, we have some other things working here. We not only have the movement of the stock that affects option prices, but we also have movements of volatility and movements of time. Say if I wanted to do a premium collection strategy, I thought a stock was going sideways, and I want to do a premium collection strategy. At that moment in time, do I care what direction the stock goes in? Maybe, but if I'm delta neutral, maybe not. Maybe I want to collect premium and not be exposed to the movement of the stock. Maybe I want to trade time and volatility and not have a movement in the stock affect me negatively. What do? I eliminate my position's sensitivity to stock movement. Where is my position's sensitivity to stock movement? Delta. That's what delta tells us. My position's movement in relation to the stock movement. If I take the sensitivity of the movement of the stock out of the equation, I could then, being delta neutral, trade time or volatility and or volatility. So I can actually put together a position that has no directional bias, but can still make money due to the passage of time or the movement in volatility. Delta neutral. Eliminate one of the variables that I'm not sure of and isolate and trade the variables that I am sure of. Time and volatility, if that happens to be my situation. So when we talk about a position delta, we're talking about the total net delta of all my call positions, all my put positions, and my stock position in a single individual issue. And if I add all those things up, add up the delta of my calls, the delta of my puts, and the delta of my stock, and they equal zero, then I am delta neutral. Now, it's not as though I happen to stumble into that. I can actually create a position that does that specifically. I might intend to be delta neutral. I might intend to not want to have sensitivity to movement of the underlying. I become delta neutral. So I know it's a little bit tough for some of you stock traders to think about it that way. You're looking at charts thinking up and down. But remember, volatility moves up and down, independent of the stock. And time passes for all of us, except me. Time passes for everybody, including options. And the passage of time can be played through something, another Greek we're going to be talking about in a few minutes. So we know the delta effect graph. That was that chart we looked at earlier. And we saw that we have a vertical and horizontal look. Delta has characteristics among different months and different strikes. Become familiar with it. I am not saying that you need to sit there and be able to rattle me off the delta of every one of the options in IBM. Let's not be ridiculous. But let's get a good idea of the characteristics of delta. Let's get a good idea that, hey, the at-the-money options normally around 50 deltas. Let's get an idea that in the money options, no matter what their delta is in the front month, they're going to decrease as we go out over time. Out of the money calls, understand, and puts, understand that their deltas will increase over time. Have a little bit of an idea of what delta looks like. So when you're choosing your options, you've got a good idea of what type of sensitivities you're going to have to the movement in the stock before you put the position on. Now, we talked about the movement of time and how it affected delta. We saw that those in-the-money options lost delta. The out-of-the-money options gained delta. That actually has a name. It's called Trumpification. Trumpification. Now, is it important that you know how to spell Trumpification? No. Is it important that you know the textbook definition? No. But it is important to understand the effect of time and volatility. Not only does time create that delta effect, called Trumpification, but volatility creates that effect. Here we are with our chart again of the delta of the calls at a 30 volatility. And we saw the Trumpification effect as we looked out over time. But remember, time and volatility go hand in hand. Not only does this time movement affect the deltas in that Trumpification effect, but movement and volatility does also. So right here, take a look at these deltas with the stock at 65.50 and a 30 volatility. These are calls. Let's change the volatility, and you can do this at home right on your trading sheets. Instead of looking at sheet number 1, we're going to go to sheet number 5. Nothing has changed except the volatility. We took volatility up to 70. That's what sheet number 5 has. Take the deltas right off of sheet number 5. Look at the difference. Don't look out over time, because now you're looking at also time's effect on top of everything. Let's just look at volatility's effect. Let's go back to sheet number 1 and look at the range of deltas here. Because if volatility really creates a Trumpification effect, if it really crunches these deltas, we should see the deltas of these in-the-money options decrease, and we should see the deltas of these out-of-the-money options increase. The range should tighten. And it does. Now, all of a sudden, remember we had these two options were 100 delta. Now, one's 96, the other's 88. These two options were 0 and 3 deltas. Now, one's 12, the other's 23. We not only have time affecting us in terms of this Trumpification, this delta crunch, where our in-the-money options are losing delta and our out-of-the-money options are gaining delta. It's not just time doing it. It's also volatility. And when you combine the two, time and volatility, look how tight these deltas are here. Look at this range. It's basically 50 to 80. That's a tight range of deltas. And look at these options in here. You've got 3 options, the 60, 65, and 70 strike, that are very close to, they're all very close. That's that delta crunch I was talking about. Remember that, because in high volatility situations, you might start to see deltas that are really aberrations. I had a situation one time in a stock I was trading that was being taken over. Volatility went through the roof. It wasn't just 70, and it was a similarly priced stock. Stock was trading around $60, $65. Volatility in the front 2 months went to 200. Think about the crunch here. Every single option was like the same delta. But we know that that's not possible. You can't have all these options, all these different strikes with the same percentage chance of finishing in the money when the stock is right here. When these all crunched, a lot of traders got confused because suddenly, when we went to hedge ourselves, we were hedging every single strike the same way. Created a massive problem, and when June finally expired, many traders found themselves either gigantically underhedged or gigantically overhedged. Why? Because it was back in the day, before we really understood the statistical reference and the statistical situation and concept of Trumpification, and how Trumpification is not just caused by time, but it's also caused by volatility. Here is our Trumpification graph. As you can see, these are the deltas of calls. 0, which would be the furthest out of the money, 50, the at the money, 100, the in the money. And this chart here was taken right off your sheets. I took them right off the sheets. If you take a look at the in the money calls, you see that as we go out over time, we're losing delta. Finally, we will tighten enough where it'll stay constant, but we're talking about years and years out. We also see the out of the money calls gaining delta. Why is it called Trumpification? Look at that. I stick that part in your mouth, tell you to blow. It's like a trumpet. It's the shape of the graph. Trumpification. We just need to understand what delta looks like, how it looks, and how it functions. And when we understand these things about delta and its characteristics, we're going to have a much easier time hedging our position against potential adverse stock movements. That's about it with delta and the basics of delta. As you're working through delta and using your sheets at home and doing your own homework and practicing with maybe a paper trading account, you'll probably run into a lot more questions about delta. And we're going to be here to answer those questions. Just go to our website and take a look about some Q&A webinars we'll have where we can answer more specific questions you have on delta. Chris, over to you.
All right, Ron, now it's pretty good. Now, obviously, delta is an incredibly important Greek. There are others out there that we're going to go over next in the next DVD. Now, when I understood delta, it just turned on the lights in the room when it came to options trading. And I was able to build off of my understanding of delta when I understood all of the other Greeks. So the next thing that we're going to cover are those strike-based Greeks. Before you do that, make sure you have a good understanding of delta. OptionsGPS.com, go to the community, take the quiz and pass the quiz, and then we can talk about strike-based Greeks.